So I walk into the lecture hall and I sit, staring at Maxwell's equations apparently. But after I got home from university, I got a little bit bored and decided to make an entire drone from scratch. Let's just say I didn't use Maxwell's equations. Instead, I used my head and ended up learning electronics, control theory, resonant vibrations, and other nerd things. The crazy part is, for 5 months straight, I had fun the entire time. I made the electronics and mechanical parts, tested them, and of course they didn't work the first time, so I sit there in my chair, literally thinking of what went wrong. Then I redesign and repeat for 5 months. From the outside, it looks like I'm having the worst 5 months of my life. If this was an engineering course or exam, it would be. Please help me! But I'm just over here, and I feel like I'm playing. So how did I get here? If you take a look at this, it looks pretty boring to do. This is KiCad, a software used to design electronic circuits and printed circuit boards. Now look at this. This is a video game called Factorio, where you land on an alien planet and you have to build up your factory to make things in order to get off of the planet. Believe it or not, people get addicted to placing down conveyor belts. I would know because I'm one of those people. In Factorio, this alien planet is a blank canvas and a giant puzzle where you can be creative and figure out how you build your factory. KiCad is also a giant blank canvas, which you can build upon to eventually make something real and hopefully work. So to me, working on the drone did feel like playing a video game. Now that I think of it, I think I know where I got this play learning from. I remember when I was in 5th grade, I asked my mom to get a video game called Kerbal Space Program, because I thought launching fictional rockets into a fictional solar system was very cool. To convince my mom, I said, it's educational. In retrospect, I was 100% correct, but not in the way you would think. So in this game, you build your own rocket, and then you control the rocket to get it into space. But I kept crashing back into the planet. I couldn't get into space. I really wanted to get these green guys to be in space instead of on the ground. So I kept trying while facing the seeming impossibility of rocket science. Well, turns out, trying random things and turning the rocket sideways on the way up gets the rocket into orbit. Boom! Or not boom, because I didn't crash this time. Now, I didn't learn any rocket equations, but you know, at the age of 10 or so, I learned the basics of rocket science. This was one of my first things that got me hooked into engineering. It's also when I experimented my way to victory. I channeled a bit of that experimentation energy for my drone project. I didn't know how the drone would fly when I was about to test it for the first time, so I just strapped it to a camera tripod to find out. Oh my goodness. Other times, I had to play around with different designs. I remember how I redesigned the drone frame like 4 times to dial in the stiffness, and at the time, I didn't know how much of an effect vibrations and wobbly parts had on the drone, but testing the drone for real made me learn about it very quickly. So there's a good amount of this kind of experimentation in engineering. I mean, the engineering design process is literally design, build, test, redesign. It's iterative and experimental at its core. But now engineering is shown on a chalkboard in a lecture hall. And a few seconds later, Maxwell's equations pop out of nowhere to give you a jump scare. If the only thing I ever saw about engineering were the equations, I would have been too scared to try the very things that taught me engineering in the first place. Now, the good thing is, I experienced the engineering before I had to learn the equations themselves. I still do that today by making custom PCBs, which are made by PCBWay, who are actually sponsors of this video. PCBWay allows me to take my ideas and turn them into real things. Once the ideas are laid out in KiCad, I can send the design over to PCBWay, have it made and shipped to me within a week. The fast turnaround is pretty great if I experiment and find a problem. I can redesign and quickly get a new PCB and keep learning in the process. Okay, back to the video. Experiments are awesome, but what if you can do that in your head? Well, that's a thought experiment, where you use your imagination to visualize what will happen in your head, and I really love doing this. I remember this time I was working to get my drone to fly well, but something was wrong. Well, one day, I sat there imagining possibilities, and for some reason, I thought about those springy door stoppers that make that funny noise and how they vibrated. Well, it turns out that the sensitive circuit board on my drone is vibrating like that very door stopper. I did a quick experiment to see if my imagination was right, and it was. I really learned and experienced resonant frequencies that day. I had the intuition behind it thanks to the imagination. Einstein said something about imagination. He said, imagination is more important than knowledge. Now, I'm not Einstein or anything, but like, I did use my imagination. Like, come on, that's pretty cool, right? Anyways, using your imagination to visualize what happens in your head, it's pretty cool. Pretty useful as well. But you know what else is useful? Combining ideas together. Now, if you've ever played with Legos, you probably have experienced taking apart your Lego sets, putting all the pieces into a giant bin, and then using those parts to create whatever you had in mind. Engineering seems to just be the grown-up version of Legos, where you use your creativity to design and put different pieces of tech together to make something work. When I was younger, my dad gave me this Lego robotics kit. It was awesome. And it had all these sensors and you could code the robot pretty easily. Now, I wanted to make a self-balancing robot, so I got the parts together, and it turns out I don't have a sensor to make it work. The YouTube video that I had searched up showed a Lego self-balancing robot, and it had this thing called a gyro sensor, but I didn't have that. I really wanted to make a self-balancing robot. Oh well. But wait, my kit did have a color sensor and a distance sensor. My brother in Christ, I came up with the most creative solution I have ever come up with in my entire life. I strapped the distance sensor to the front and the color sensor on the back, so whenever the robot leaned forward, the distance sensor sees the distance decreasing and the robot moves forward to counteract the tilting. If it leaned backwards, the color sensor would detect the white carpet and move backwards. And it worked. I mean, look how confident 12-year-old me was. Come to think of it, engineering is sort of like an art form. Painters start painting, then build upon their ideas with their strokes. Engineers start ideating, designing, building, and testing, and then build upon the ideas they have to make the final version. Of course, engineering always has that scientific aspect to it, using the physics, the equations, and of course science to make things work really well. And that's great. Okay, so creativity, imagination, experimentation, all very important for engineering, but it takes a good amount of brain power to do. So it would be pretty cool if we can harness this. Boy or girl, do I have something for you. The answer is to simply do a lot of the things that require that kind of thinking. If you play a lot of chess, you tend to gain the ability to think like a chess player, for example. If you want to think like an engineer, then the theory is to do a lot of engineering. But that sounds hard. Well, just like how I love to play nerdy video games like Kerbal Space Program, I think the key is to have fun with it. If something is pretty challenging but it's fun, then it'll just become another hobby, not a chore. I went skiing a few months back and it was pretty scary. And pretty hard. But it was also fun, so I just kept doing it until I basically reached the Blue Hills, I think. So yeah, basically just do things that allow you to use your imagination, your creativity, and your experimentation skills, I guess. Engineering projects require all of those things. Best part about it? You can keep going for a long time because you enjoy it, and often complex skills like ones used in engineering are learned over the long run. And actually, I think playing helped me on my engineering exams quite a bit. Not to flex, but I'm pretty cracked. I mean, it helps that play trains how you think, which is a pretty essential part of engineering. So there's this quote that I remember that someone said from somewhere, which really narrows it down, and it goes something like this. I hear and I forget. I see and I remember. I do and I understand. So just do it, I guess. When I was younger, I didn't know that playing would become one of my best teachers. The topics in engineering are inherently hard and complicated, but how you learn it doesn't need to be. And maybe it's worth it to harness your inner child.